We already know what registers are available in x64 processors. Now we will describe the data types which can be stored and processed in these registers. Let us start with fundamental data types. They cover the types of data elements that are stored in memory as 8-bit, named byte, 16-bit, named word, 32-bit, named double word, 64-bit, named quad word, or 128-bit, named double quad word. Many instructions allow for processing data of these types without special interpretation. It depends on the programmer how to interpret the inputs and results of instruction execution. The order of bytes in the data types containing more than a single byte is little endian. The lower, or in other words, least significant byte is stored at the lower address of the data. This address represents the address of the data as a whole. The data types which can be used in our x64 processors can be integers or floating point numbers. Integers are processed by the main CPU as single values called scalars. They can also be packed into vectors and processed with the specific SIMD instructions, including MMX, SSE, and AVX. Integers can be interpreted as unsigned or signed. They can also represent the pointer to some variable or address within the code. Scalar real numbers are processed by the FPU, SSE, and AVX instructions. The SSE and AVX support also calculations with vectors composed of real values. All possible variants of data types are stored within the fundamental data types. Integers are the numbers without the fractional part. It is possible to define a variety of data of different sizes, all based on bytes. A single byte forms the smallest possible information item stored in memory. Even if not all bits are effectively used, the smallest element which can be stored is a byte. 2 bytes form the word. It means that in x64 architecture, word data type has 16 bits. 2 words form the double word of 32 bits. 4 words form the quad word having 64 bits. With the use of large registers in modern processors, it is possible to use in a few instructions the double quad word data type, containing 128 bits, sometimes called octal word. Unsigned integers are encoded in natural binary code. It means that the starting value is 0 and the maximum value is formed with bits 1 at all available positions. For example, the byte of value 0 has 8 0 bits, and the maximum value of 255 is represented by 8 1 bits. Signed integers are encoded as 2's complement values. The highest bit of the value is a signed bit. If it is 0, the number is non-negative. If it is 1, the value is negative. It means that the starting value is encoded as the highest bit equal to 1 and all other bits equal to 0. The maximum value is formed with a 0 bit at the highest position and bits 1 at all other positions. Integer vector data types were introduced with SIMD instructions, starting with the MMX extension and followed in SSE and AVX extensions. They have the form of the packed data types containing multiple elements of the same size. The elements can be considered as signed or unsigned, depending on the algorithm and the instructions used. The 64-bit packed integer data type as used in MMX extension, contains 8 bytes, 4 words, or 2 double words. With the growth of the size of SIMD registers, the number and size of packed elements also grow. Used in XMM, a 128-bit packed integer data type contains 16 bytes, 8 words, 4 double words, or 2 quad words. With the appearance of YMM registers, the 256-bit packed integer data type contains 32 bytes, 16 words, 8 double words, 4 quad words, or 2 double quad words. Double quad words are not used as instruction operands. They are the results of some operations only. The 512-bit packed integer data type, introduced in AVX 512, extension contains as many as 64 bytes, 32 words, 16 double words, 8 quad words, or 4 double quad words.